Alright, so for this video, hopefully I found some videos and kind of tagged it to talk about the general periodic table behaviour. But basically, phenomena is seen all the time in the physical world. So for example, there's a couple of them in front of us. So seasonal variations in our climate, variations in average, maximum, minimum monthly temperatures, number of daylight hours at a particular location, tidal variations and the depth of water in the harbour, phases of the moon, animal populations, etc. So these can all be kind of represented in a periodic pattern. So what that means is, it's repeated over time. It could be they're periodic, oscillating, cyclic. So in the unit circle example, we worked kind of with a circle where you started from 0 and then get to 2 pi with 360 degrees, and then it does that same motion over and over again. Okay, so that's also known as periodic, and what we're going to do is we're going to move this circle kind of behavior into a more of a wave type graph. So we'll have a look at what that looks like. So as you can see, this is about the temperatures, and we read just above that temperatures can be seen as an oscillating pattern. So if we graph this, you will see something like this. I'm not going to get you to graph it, I'm just going to get you to have a quick look at it. So as we sign it, you can see some sort of graph happening, and it's hopefully going to keep continuing the pattern. The temperature shows the variation from an average 28 degrees in January throughout a range of values across the months. The cycle will approximately repeat itself for each subsequent 12-month period. By the end of the chapter, we were able to establish a periodic function which approximately fits this set of points. So at the moment, we have up to here, that graph over here, let's just copy and paste it. But what we do know is, it continues over the next 12 months because it comes back to January. So this just repeats over and over again. For the next few years, obviously we're not thinking about stuff like global warming and stuff where it heats up, but we're just assuming it's a cyclic, periodic pattern that it happens over and over again. It's, at a certain pattern period of time, it's going to be the same pattern over and over again. So some terminologies you'll find useful to write down. So please write this down in your book. I don't know why this isn't going away. Periodic function is one which repeats itself over and over in a horizontal direction, so it's going that way in intervals of the same length. So that's very important, intervals of the same length. That shouldn't change because then it changes the pattern as well. A period of a periodic function is the length of one repetition or one cycle. So how long has this lasted for? Well, January to January, the period would be 12 months. Alright, f of x is a periodic function with period p if f bracket x plus p bracket equals fx for all x and p is the smallest positive value for this to be true. Okay, so you can just copy those points down under the title over here, terminology used to describe periodicity. A cycloid is an example of a periodic function. It is a curve traced out by a point on a circle as the circle rolls across the flat surface in a straight line. So let's say this point we're drawing, so as it rolls around it draws this sort of pattern, and it's the length of it's going to be the same, so that's called a period. In our case, we're just going to start using those mathematical terms. It's not going to shorten or anything, it's always going to be that constant length, same period. So that's going to be constant. If not, we can't call it a periodic function. Wave also takes this oscillating pattern. So periodic, do you see how, if I start from the top and finish at the bottom, it's going to repeat itself at the same interval as well. So the intervals, the period is going to be the same as well. So you can hopefully see that. And this is what we're going to be closely working with. Hopefully you've drawn a sine wave and a cosine wave and seen that it actually is a wave on the graph. This is very important. I want you to write all of this down. Please write it really neatly, put a highlighter box around it because it's going to be something that you come back to every time. Alright, so the wave properties. These are some of the wave properties. The wave oscillates about a horizontal line called the principal axis, which is just this kind of midline, or mean line we call it, which has the equation of y equals max plus min over 2. So it's basically averages out the maximum and the minimum. It's just a halfway point. So that's called the principal axis or the mean line. Maximum point occurs at the top of the crest, so this is called a crest, and that's called the maximum at the top. Minimum point over here is called, it's at the trough, it's the bottom of the trough, and that's pretty simple. The amplitude is the distance between maximum or minimum point and the principal axis. So what that means is from the principal axis, it's the distance to the top or distance to the bottom. So not the whole distance. Alright, the amplitude is just going to be half of it. So that length, or if I draw it, the bottom one, it's going to be that length. But it should be the same, okay? Because remember, we averaged those to maximum and minimum to get the principal axis. So it should be halfway between, meaning these two arrows should have the same distance, which is the amplitude. If you want to find the amplitude, this is the formula you just need to write down and figure out. So that's a summary of basically what I've just kind of told you. Copy this graph down nice and neat. So you've got the principal axis, maximum point, minimum point, and as you can see, from the halfway point to the maximum, it's called an amplitude. Also similarly, from halfway point to the minimum point, which is that top of the bottom of the trough, should be the same amplitude. So make sure you understand that. Period is any same point to the other same point. So if I start halfway through, you can come back to the halfway through. So this is a period, right? It does one oscillation, it goes up, finds the maximum, finds the minimum, that's one, and then it's just going to repeat that over and over again, etc. Okay, so that's the period we talked about. So make sure you draw that graph. And then moving on, you just got to do question 1 to 3. Give it a go. Let me know if you need any help.